One trend I've noticed in the interviews I've conducted for this Greentech Pulse is that most of the innovations that are helping us get more sustainable tend to take us back to nature because when you look at it, nature knows best. Nature does things in the most efficient ways. And today's entrepreneur is doing something like that too. His field is in the field of refrigeration. His company is PRO Refrigeration, and he's going to tell us what innovations he's doing in the field of refrigeration and why this is necessary, as long as much as we can talk about. So, welcome to the show. Welcome to Green Talk Pulse, Jim.
Thank you, Peter. Thank you for inviting me.
Thank you. Thank you so much. So now you talk about pro refrigeration. What does it do differently in the field of refrigeration?
What we do is we cool milk and we cool beer. Those are we manufacture chiller systems, and but those are our specialties. We've been in business for 35 years, and the focus from the start has been effectively cooling milk and designing equipment to instantly cool milk. And then when breweries came along in the 1990s, craft breweries, we evolved our equipment to also support that industry.
Amazing. So why did you choose milk and beer? That's an interesting choice.
The dairy part of it was I was born into it. My grandfather and my father were both involved in the milk cooling business, and from then the it evolved, and the process of cooling milk evolved. When my grandfather started, that was right when refrigerated milk tanks, the storage tanks where milk was cooled, had just been invented, and he had the training, so he got and started literally at the ground floor of refrigerated milk, and then that was in the early in the 1940s and 50s, and then as farms grew, it became harder and harder to cool milk. And then that's when my father began developing chiller systems specifically to cool milk, um, a process called instant cooling. And that's now that's the standard process used in the United States on large farms. And it's something we continue to try to get better at and continue to perfect, and yeah, find better ways to cool milk more effectively. And CO2 is actually allowing us to do that, and it's exciting. It's an exciting time.
You just mentioned them. Yeah, you just mentioned CO2. I know usually when we are talking about cooling, we talk about things like the Aru, I think one Aru something that we use in the 80s and the refrigerators these days. So you mentioned
Mhm.
CO2. Why CO2? Why did you pick CO2?
CO because it's a refrigerant. It's a very good refrigerant, and it's a refrigerant that's been around for over 100 years. There's dating back into since we started this project, I get a lot of people mentioning it and sharing stuff. But the challenges with CO2 are the same as they are today. It's very high pressures. It's hard to manage. The piping on it is it takes more piping. It's harder to the control system has to be more advanced. So there's just more challenges to control the CO2 and effectively use it. And that was the some of the drawbacks to why we haven't seen CO2 used more commonly than it is used.
Yes, because I think just before the show, I was talking about. I know I've heard of CO2 being used before, but when I saw the this thing CO2, I'm like, wait, I haven't seen none of the cooling things in my house uses CO2. Why? So yeah, so your explanation now, the pressure, the piping, and everything, it now makes it make more sense because from that means it will probably be a lot more expensive building CO2 cooling systems than using the conventional ones. So now looking at this, I would say would using a CO2 cooling system, like I just said, that's an assumption, but from the
Mhm.
experts, would it be more expensive than using the normal cooling system?
Yes, it is. It is, and that's why it's the The customer base is much smaller for a CO2 based system. For us, even in our customer base, it's the larger. We're really focusing on the larger applications and larger consumers. Those are the ones where it's more feasible because of the added costs.
Yes, yes. Okay. So now for those businesses now, they are spending more on cooling their milk, their beer with CO2. What are the benefits? What are the advantages of using picking CO2 as their choice than the conventional?
It's there's a couple different ones. The From an efficiency standpoint, CO2 is more efficient than traditional synthetic based systems head to head. The reasoning is not because CO2 is a it's not strictly because CO2 is a better refrigerant only. The main reasons are, or some of the big reasons are, it's the more advanced control system that we use, and then just the overall system design that coupled with it. But all those together are what help it to become more efficient on a head-to-head basis. But it's not the CO2 system is not more efficient enough that it's really the difference maker for someone to justify the expense. The difference maker to our customers has been the waste heat recovery. And that's where they recover the waste heat off of our system. So we're taking the heat that we're removing from the beer or milk, and then we're reusing that heat, and then they're converting that into hot water. So they're generating all of the facility's hot water by recovering the waste heat off of the cooling system, and that has really been the game changer. Where we're literally becoming the primary hot water heating source on farms, where before they were using a natural gas or a propane heater would be used for their hot water heating. And farmers, dairy farms in the United States especially, they use a tremendous amount of hot water for sanitation and for cleaning, and so it's a very big expense for them to heat the water and for fossil fuels. So being able to get that improved waste heat recovery, that's been that's really been the difference maker, and the reason that we've been able to get the systems that we have out there currently operating.
Okay, so I know generally, I know from my maybe rudimentary understanding, I know a cooling system would pull the heat out of the contents and send it out. So that's probably the waste heat that you get. So when you say hot water, how hot are we talking about?
We can go, I'm talking Fahrenheit, but to 180 degrees Fahrenheit. So almost to boiling, as hot as you would need. Yeah, it's a game changer versus traditional. Our traditional systems also have heat recovery, and we offer it, but it's not nearly as effective. On traditional, I can recover at best maybe 40% of the waste heat, where on the CO2 we can get 100% waste heat recovery. And then the other drawback with traditional cooling is the refrigerants are at a lower temperature. So instead of heating on the CO2 where we can heat to 180 degrees, we are only able to heat to 135 or 140 degrees on a traditional system. So the CO2 offers us a higher temperature and a higher volume of water that we're able to heat.
Interesting, because I think that's actually a really big reason people should choose this. Because generally, I know, yeah, like in the house, anything heating, anything cooling is my biggest energy consumer. So if your cooling system can provide heat for you, you've gotten rid of a lot you'd have, yeah, spent on. Interesting. So now, apart from these savings on heating, on hot water, and the waste heat recovery and cool, what about regulatory changes? Are there any regulatory changes in the industry, maybe in the dairy industry, in the beer breweries, or whatever, that would make businesses in these industries want to go with a CO2 cooling system?
The regulations are not industry specific. They're except that they are on a national level and a state level. They are impacting the refrigerants that we as a manufacturer are able to utilize. So my company that builds chiller systems, both traditional and the CO2 units, after I believe the deadline is currently January of next year, we will no longer be able to use our current refrigerant. We will have to, the standards, which are, as I believe you mentioned, is that global warming potential, or there's a rating that is used, but they keep lowering that rating, and the rating will again get lowered, and it forces us, as you said in maybe our previous conversation, it's all leading to us trying to get to that CO2 or that rating of 1 that we're able to get to with CO2. And then other natural refrigerants like propane also will get us very close um, to that low GWP goal that we're all trying to get to.
Interesting.
Mm-hmm.
Interesting. So now, okay, so that means with the regulation that's coming due in January 2026, that means you're not able to manufacture cooling systems with the refrigerant you use, but people who probably own those equipment can still use them.
Absolutely, many years, yeah. Yeah, and what we will be forced to do is just to use a slightly better synthetic refrigerant, and then that will have a slightly lower rating, but really my team's goal is to get to a natural solution as soon as possible, and try to limit the incremental steps that my company, we've made. Every 7 to 10 years since we've started, we've had to re-engineer all of our equipment as the regulations have changed and tightened up. And it will be nice to finally get to, we've gotten there with CO2. Now we just need to expand the product offering, but it will also be nice to get there with propane, that we think is going to be the other big refrigerant that we will be utilizing in the future.
Okay. So now let's talk about the technology. When we a lot of times when we have conversations on global warming and things like that, we talk about carbon capture, we talk about the CO2 levels in the atmosphere causing probably different issues and all that. So now, how does your system work with CO2? Where does it get the CO2, and how does it play in this entire carbon capture and whatever cycle?
Mm-hmm. That's a good question, because CO2 in a lot of sustainability circles it's a bad guy. It's the byproduct of burning fossil fuel. But what we're doing, we're capturing that CO2 out of the environment, and we're cleaning it up and we're scrubbing it up, and then we're putting it to work for good. And we're replacing the synthetic refrigerants with the CO2 that we've captured from the environment. We don't it's a closed system. So once we capture it and we put that CO2 in our system, it's not like having to fill up your gas tank. It stays in the system until there's a leak or until the system is opened up. But otherwise, that CO2 is just reused and continues to be utilized.
So now, for a typical dairy farm or a typical brewery, can you probably share? And I know you already gave the example of the waste heat recovery and
Mm-hmm.
the hot water production from the system. So can you probably maybe give us maybe another or any example of any brewery or whatever that has adopted your system, and maybe any, the benefits, real time benefits, real life benefits they've had? So probably the listeners can visualize it.
Yeah, additional benefits. We have one of our CO2 systems is operating up in Alaska at a brewery distillery. For them, power is so expensive. The cost for their power. So for them, it was, even though the operating efficiency of the equipment was not as um, wasn't there wasn't a big difference. There was a difference enough that it made a very big difference in Alaska, where they were paying very high prices for their power that was being generated remotely. So in that case, that's a perfect example. Another one is the cost of the refrigerant. Every refrigeration system at some point is going to lose its charge, or the refrigerant charge will leak from the system. and the cost of refrigerants and systems will have typically 500 pounds of refrigerant, and the cost just keeps going up. Where CO2 today is about 1/10 the cost of a comparable synthetic based refrigerant. So yeah, it's a definite cost savings too, is another big advantage. Um, and in the United States and elsewhere too, with CO2, we have far fewer regulations. The Environmental Protection Agency in the USA is the governing, over refrigerants. They have they don't have the same authority over over the systems with CO2, um, because it's not a synthetic based refrigerant and it's outside of their jurisdiction. So that frees up a lot of our customers from a lot of the reporting and the paperwork and a lot of the filing and the administrative work that is only going to increase in the United States too with synthetic refrigerants. It'll the workload in that will only become higher. We see.
So I think that that's actually a lot. That makes a very interesting use case. So you have the power cost, the heating cost, you have the refrigerant cost, and I can actually relate to that because I just worked on my car AC last yeah last month, and it cost a lot just for a small can of refrigerant. Yeah, then you have the paperwork, which is actually really interesting because when you say you no longer have to report, you no longer have to file a lot of paperwork because you're not using a synthetic refrigerant. I think that cuts a lot of cost, a lot of process out of the business. So I think these are three really big reasons. Truly big reasons. Yeah. So Anna, apart from that, you talked about that regulation for the manufacturers and the type of refrigerant they can use coming in January 2026. Are there any other regulations, probably for businesses on the systems? Because you mentioned the EPA, so the systems they can use or the refrigerants they can use or anything that businesses, especially in these fields, the dairy and brewery field you talked about, are there any other regulations maybe upcoming or existing that they should be aware of?
I think a lot of them are along that same timing that I said. California has some specific regulations, and I've got some very smart people on my team that are much more versed on the dates and the details of it. I wish I knew more about them, but there are some critical dates and some other. This also the California Air Resource Board, or CARB, as they're known to. They're very involved in the emphasizing the reduction of the fluorinated gases and trying to get the advancement of it. So they're really leading the way. They and I can share briefly, not necessarily a regulation, but it's an incentive program that they've put in place for customers in California. And what they some positive things that I've seen with this program, when they first opened it up to us, a lot of my customers didn't qualify because the qualifications to receive any of the incentives, it required the system that you were replacing to have a much higher refrigerant charge than our systems did. So it took the but they have since opened those qualifications up or reduced that limit on the charge limit. So now, for us, it's huge, and the impact will be great because it opens the qualifications up to almost all of our customers in California. And what we're hoping is that'll be a first step, and then opening it up for the rest of the country. But that and this program is just one program, and it's a limited fund. That once the fund is used up, it will go away, so it won't go on forever. But it's a great one to help to help encourage people to make the shift over. And it almost covered the total difference in cost between our synthetic system and our CO2. So it almost covered the whole. So it almost eliminated the added cost justification that is a big part of it.
Okay, so I think you just mentioned the added cost, and I know we talked about earlier.
Mm-hmm.
We talked earlier, yes, about it being a bit more expensive. So when you say added cost, like to what degree? Let's say a business has your synthetic system and the
Mm-hmm.
CO2 system. To what degree is the CO2 system more expensive than the synthetic?
depending on the final configuration, but it's 30 to 50%. And if you think about it in scale, a synthetic system that we would sell for around $200,000, we would offer the CO2 for 300,000. So it's an additional $100,000 on that scale. But it's yeah, big dollars. No, and the other positive is it's dropping. We as a manufacturer, we're getting better. We're it's still a small part of our business, the CO2. So we're still learning with every system. But my goal, and I'm challenging my engineers and our production workers, that we need to we need to build all of our systems, whether any refrigerant, and there's good opportunities. I think we'll continue to see the difference get closer together.
Okay. So now, apart from the 30 to 50% additional cost that they would experience while maybe upgrading from a synthetic system or choosing a CO2 system over a synthetic system, what other challenges, what are the biggest challenges a business trying to upgrade their cooling system to this system would, what kind of challenges would they face?
They, I mentioned that CO2 is much higher pressure, so the 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 skill level of the service technicians that take care of the equipment doesn't it. I don't want to say it needs to be higher, but it needs to be expanded. Meaning that you could take a skilled technician who's only familiar with synthetic, and we provide the training, but we have always been able to expand that person's skills to adapt to the CO2. It's very easy, and they very quickly adapt. And we cover both safety training, skill training, and then theory. But it's a lot the same. There are not a lot of differences. Just a few key things that they tend to pick up very quickly. And then and as an example of it too, something that I didn't expect, but we even have some of our customers. These are farmers. They have very skilled labor they have skilled labor on their facilities, but we've learned that some of them are even doing a lot of the own maintenance work and 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 service work. They'll still rely on the contractors and the specialists for the important stuff, but for the day to day and the checks, they've trained all of their own staff to take care of it, and they're comfortable with it.
So now, in this CO2 refrigeration, I know you mentioned the pressure being needed, more pressure being needed, and stuff like that. So, but
Mm-hmm.
you've also mentioned that with the improvements in technology and code, the cost is coming down. And so now, what innovations in this field of CO2 refrigeration do you see coming that would probably help the cost come down more or make it more widely accepted?
I think that I our system is we're using the same control system that you would see in a supermarket. Very industrial, very heavy duty, and very high tech. Um, there's probably much of the control that we're not utilizing. So I think we're going to see simpler controls, maybe that will still provide the needed technology, but you'll see the costs drive down to that. Right now, I think we're 4 or 5 times if you compare the control packages between a traditional system and a CO2, just the controls, just the computer control cards is almost 400% more expensive than our traditional. So the controls themselves are a big part of it. The and I think the components, all of those costs, we'll see those come down also. So I think it's just a matter of time.
Okay, so there's one question that's been nagging at me since you mentioned beer, chilling beer, and
Uh-huh.
milk.
Hmm.
The
Hmm.
difference, what's the difference in the requirements for chilling milk and chilling beer? I know you
Uh-huh.
talked about instant cooling for milk, so I think that's one.
Yep. Yep. Yeah, that is those are the two differences with milk. With milk, what we do is we put a heat exchanger that sits between the milking parlor and between the milk storage tank. and after the milk leaves the cow, it's transferred from the milking parlor to the milk tank, but we cool it as it's being transferred. So we only get one opportunity to cool it. So it's a very critical process. But that is where the magic happens, and that on a dairy farm. For in comparison, on a brewery will put a central chiller system in, and they'll run a big cooling loop around the brewery that and they'll run individual cooling lines to multiple beer tanks, and each beer tank can be cooling, one can not be cooling, and they just control their each of their tanks by pulling off of a centralized cooling loop. And so one uses a loop and the other one uses a single heat exchanger. Is would be the main difference between the two customers and the two industries.
Interesting. And I think from your explanations for both industries, I can see why you had to specialize on those two because they have unique needs, and you can't just probably go and pick something off the shelf and say you want to cool beer or you want to cool milk. You need to know the requirements.
That's it. Yeah, and there wasn't in both industries. Yeah, there was no defined way to cool it. The milk in the past had been cooled in milk tanks, and over a longer period of time. So it's always been fun and interesting to to try to figure out new and better ways to do the job.
Okay, so now for these industries that you serve, what changes do you see coming in the next maybe 5 years, the next 10 years, especially in these aspects of cooling and refrigeration that they should be aware of or they should be aware of?
we're we're going to see the restrictions, continue to get tougher on the synthetic refrigerants, which I think is good. And you'll see it's going to continue to push everyone towards the natural refrigerants. I think in 5 years, um, we our company will be manufacturing a lot of systems that utilize propane as a refrigerant, and I think we'll have a mix of our smaller systems will be propane, and the larger systems will use CO2. Is how I would envision um, the our factory will look at in the future.
Amazing. Yeah. So okay. So
Yeah.
now, yeah. So now looking at the industry generally, and especially with cars, because I mentioned having to
Hmm.
refill
Hmm.
refrigerants in my car last month.
Yep.
What changes do you see? How do you see CO2 adoption growing in the next few years? Is this something that you feel would be adopted in cars, general home air conditioners, and co?
Yeah, absolutely. I think with electric cars, especially, you're seeing CO2 heat pumps are being put in, and CO2 driven heat pumps are becoming in the United States are becoming more and more popular for apartment complexes. As a heating source. Our company's worked on a couple projects where we've built some systems under custom systems for those projects, and I think that's going to be a growing thing. You'll see also CO2 as heat pumps.
So now for businesses in these fields, breweries,
Hmm.
and dairy farms that are looking, maybe they've listened to this episode and they're looking at switching, or they're looking at being more sustainable, or like you said earlier, saving on heating and things like that. And
Hmm.
paperwork, very important. I hate paperwork.
Yeah,
what
yeah.
advice would you give them?
I would, if you know, depending on the scale that they're looking at. If they're on the industrial, heavy commercial scale, I would follow the same path that we did, which was we looked really hard at what the supermarkets were doing and the supermarket industry and what the data center industry is doing. And the reason I say that is even though those might not be your industries, how they're applying the cooling and they're testing the new technology. They've got big money behind them because they especially on the data centers where they're looking at the most effective way to cool and maintain all this added AI cloud storage that's required. So it's we're really seeing a lot of exciting development coming out of that. So that's where I would focus. And yeah, and I would don't sacrifice. You know, that's the other thing is that I had always kind of thought of in the past is if you were going to go CO2 or any natural, expect to either sacrifice on a capacity reduction or sacrifice on a not as efficient of operation, and a lot of this, but none of that is true. I mean, if you have to sacrifice too much, I would probably not make the move yet. But because I think there's enough positives that if you make a good business case, you can find it, and that's what that would be my suggestion. And then just verify when you're done that you're getting the performance and the operation that was either promised to you or what you expected.
Okay, so verify that you're getting whatever was promised to you. Check what you're sacrificing to make the switch, and
Yep.
yeah, so I think that's basically really great advice. And look at the supermarket and data center industries, what they're doing, and look at everything. So now I think I've enjoyed this conversation so far. I really love technology, new technology, and talking about this has really opened my mind to new things. And I know you love anyone listening to would probably enjoy it this much. So for anyone else who wants to continue this conversation, they want to learn more about what you do at Pro Refrigeration, probably maybe they want to
Hmm.
install your system or go with your
Hmm.
system or whatever. What's the best way they can reach you?
Our website is www.prochiller.com, and you can reach anyone on the team, including myself, from there. I am very active on LinkedIn, and we have a lot of our team members. You can find us on LinkedIn. So I think I'm LinkedIn /Jim VGJR, and that will link you to my profile. But we would love to talk to you. And on our website, that prochiller.com, we have a pro green solution page, and it's turned into an archive. We started that almost 5 years ago when we first started developing the first system. So it's really neat to go back there, and you'll see a nice collection of articles, press releases, and just stuff that kind of chronicled our journey as we expanded, and we're starting off to a good year too. So keep tabs on it too. It's exciting to see just to see other farmers start to take notice, and I think this is we're gonna see much more acceptance, which we're excited to see.
Thank you so much. So prochiller.com, that'll be on the show notes on the screen. Once this goes out, don't forget to check the Pro Green section out on the website. And you can look for Jim on LinkedIn, connect, continue this discussion. So thank you so much, Jim, for coming on Green Tech Pulse and sharing with us this morning. Thank you. So for the listeners, I think you've learned a lot about Pro Refrigeration, about using CO2 for refrigeration, how it's more efficient, how it's the benefits, heat recovery, the cost of refrigerants, and the cost of power, and as well as less paperwork. So if this is something that interests you, or you know someone else that will be interested in these topics, don't forget to share this episode with them. Until next week, don't forget to tune in to Green Tech Pulse. Bye for now.